Okay, so today we're going to talk about exponential growth and decay. So there's a generic equation for either function, and it's y equals a times b to the x. So to decide if something is growth or decay, we're going to look at this value. Typically it's in parentheses. Okay, if it's greater than 1, then this tells me it's growth. If it is less than 1, then that tells me that it's decay. So some things you should remember about the word growth means that it's increasing over time. If it's decay, that means that it's decreasing over time. So, like, for example, a real-world example, something that increases over time, would be the value of a house. So sometimes they refer to that as appreciates. And in the real world, something that decreases over time would be the value of a car. Like once you buy a car and you try to sell it a couple years later, you can't get nearly as much as what you paid for it. So that is called depreciates. All right, the other thing is, so these are going to be graphs. On graphs, it's going to look something like increasing over time. Here you're going to see it decreasing or going downward over time. Now, there's going to be a line that it approaches called your asymptote, and the asymptote is basically an imaginary line. Let's say that our asymptote is here, that your graph gets closer and closer to without ever touching. So this is called your asymptote. All right, and your asymptote is indicated by whatever number is over here. And that's always going to be a horizontal line, like y equals whatever that number is. Okay? So that's one type of problem that we're going to talk about, is just basic exponential growth and decay. The other type of problem that we're going to talk about is interest. And to do that, there's a formula. It's a equals p times 1 plus or minus r to the t. So this is your account balance, or your ending amount. P is typically referred to as principal, or your starting amount. All right, R is your rate, and T stands for time. Okay, so we're going to come back to this formula later. But just so you know what these stand for, you've got account balance, that's what you end with. Principal is what you start with. R is your rate, and this needs to be as a decimal. And then your time. All right, so let's go through and do problem numbers 1 and 2. So it says, tell whether the function shows growth or decay. So if I look at this value, this is my b value, so back here, I'm looking to decide, is that number greater than 1 or less than 1? So 3/4 is 0.75, which is less than 1. So since it's less than 1, this tells me that it should be decay. In this one, 1.05, obviously that's greater than 1, so that should be growth. All right, now to do the graphing part, we're going to use our calculators, and then your graph should confirm what we've just decided. This is decay and this is growth. All right, so for number 1, you're going to just type in the equation. Okay, so you're going to go to y equals, we're going to type in 10 times 3/4 raised to the x power. Okay, so then we're going to graph it. And then we just need to plot a few points so that it replicates that on our graph paper. So you're going to go to your table. We're going to make a table of values. Now, some of these numbers get very large. So this, I think, only goes up to 10. So I'm going to pick 0, 10, 1, 7.5. You're not going to get a lot of integers, just that 1. So I'm going to skip down to like 3, 4.2, 5, 2.4. We'll skip down to 7, 1.3. Okay, so once I have my table, I'm just going to plot my point. So 0, 10, 1, 7.5. You have to just estimate there. 3, 4.2, 5, 2.4, and 7, 1.3. All right, so if I go back to my graph, notice that this graph gets closer and closer to the x-axis, but never touches it. So you might want to just draw in your asymptote. This is like our wall that says that our graph should not go below that. Okay? All right, so we're going to do the same thing for number 2. Number 2, we've got 100 times 1.05 to the x. Okay, now this one is not going to show up on our graph unless we change our window. So you're going to go to your window. Because it went up to 100, we need to make our y go up to 100. So I'm going to count by 10. So you're going to change your y max and your y scale. Then hit graph. All right, so now you'll be able to see a little bit more. So I'm going to say these are counting by tens. So this is 50. This is 100. Okay, and then these can still count by -1 to -10. Okay, so now I'm going to go to my table, and we don't want these numbers. Those are too big, so we wanted the ones that had negative values here. So if I make a table of values, I've got -7, 71.1, -5, 78.4, -3, 86.4, -1, 95.2, and we got 0, 100. All right, so this one doesn't have as steep of a change as the other one, as problem number 1, but you could still see where it's going. So at -5, we're at 78. At -3, we're at 86. At -1, we're at 95. All right, so you can see that you've got growth over time. It's increasing over time. Eventually, it's going to go way up here, right? Your asymptote is technically still the y-axis, or sorry, the x-axis at y equals 0. However, you don't really see that because we didn't extend our graph far out in this direction. All right, when you're ready, flip over to the other side. If you need to pause the video, then go ahead and do that. All right, so now we're going to do a couple of real-world examples. So Clara invests $5,000 in an account. This is what she starts with. It pays 6.25% interest per year. That's our rate. After how many years will her investment be worth $10,000? So that's how much we want it to end. All right, so starting is $5,000. This we need to change 6.25. We need to move over 2 spaces so that we're looking at it as a decimal. So our rate is actually 0.0625. So make sure you look at this as a decimal. And to go back to our notes from the other side, okay, this is the equation we're going to use. A equals P times 1 plus or minus R to the T. Okay, so we want to know what's our account balance. We want it to equal 10,000. We're starting with 5,000. So actually, we're going to leave this blank right here for now. Okay, so we're going to go A equals 5,000. That's what it starts with. 1 plus. Now, to decide whether it's plus or minus, it's paying interest. That means it's increasing. So I'm going to put in the plus sign. My rate is 0.0625, and T is just my time. So here's my equation. At this point, you're going to use your calculator. Okay, so we're going to look at our calculator. We're going to go to y equals. All right, so we're going to type in our equation. 5,001 plus 0.0625 to the t, but now you can't put in t, you have to use x. Okay, so you're going to put in this equation in your calculator. You write it first from the sentence. And now we actually don't really need the graph, we just need our table of values. So this is telling us that at 0 years, it's worth 5,000. After 1 year, it's worth 5,300. After 6 years, it's worth 7,000. What are we looking for? We're looking for when is your investment worth $10,000. So you're going to keep scrolling down. At 11 years, it's only worth 9,700. So that's not quite 10,000. So if you look at this line, it says 12. So what we're going to say is, looking at our table, right? We got 12, 10,349. So this answers my question. All I need to do is write a sentence now. So after 12 years, the investment is worth $10,349. Okay, so we're looking for a number that is at least 10,000. You probably won't ever get exactly 10,000. We're looking for 10,000 or more. Okay, so we're going to do the same thing with problem number 4 and problem number 5. All right, so our city population was initially 15,500. That's my initial amount. It's dropping, so this means decay, which means that I'm going to have minus 3%. So 3% is the same as 0.03 as a decimal. That's my rate. Okay, so write an exponential function. So we got A equals my starting amount, 15,500, 1 minus 0.03 to the t. So that was my equation in the first problem. Here's my equation in the second problem. The only difference, really, besides the numbers being different, is this is positive, this one's negative because it's going down. All right, so now I'm going to go to my table. Sorry, I type in my equation. 15,500, 1 minus 0.03 to the x, and then I'm going to look at my table, and I'm looking for when is it going to drop to 8,000. So I need to look at when does the y column go below 8,000. So if I look at 22, 79, 30.7, that tells me what it's going to be. So this tells me all right, after 22 years, the population will be 7,931 people. Now notice that I didn't say 0.7 because you can't really have 0.7 people. All right, last problem. In 1981, the whale population was 350. So A equals 350. It has increased, so that tells me I'm going to do a plus sign, at a rate of 14% per year, so that's 0.14 to the t. All right, so now here's my equation. I'm going to put that in my calculator. 350, 1 plus 0.14 to the x. Okay, so you got that in there. You're going to look at your table. You want to know when will the graph and predict when the population will reach 20,000. So we need to scroll until this y value is at least 20,000. So here's 10,000. It looks like at 31. So if you look at your table, we have 31, 20,329. Okay? So this tells me after 31 years, the population will be 20,329 whales. Okay? If it asks you specifically what year this is taking place, you need to look at 1981 plus 31. And that tells you in 2012. So it's possible you would have to answer this in 2012, like if it was a multiple choice question.